In single-stage compression, the pressure is increased continuously until the desired level is attained. When the piston moves down, the air is sucked into the cylinder. In the PV diagram, the cycle starts at pressure P1 and zero volume. The induction of air takes place until the point 1. At point 1, the cylinder is full of intake air and the volume of air is at its maximum. When the piston moves up, the volume of air reduces and the air is compressed to a higher pressure. In the PV diagram, the polytropic compression of air is represented by the curve 1, 2. Here, the delivery air pressure and volume follows the law PV power N equals C. The high pressure air opens the delivery valve against the spring pressure and flows to the air receiver. In the PV diagram, the curve 2, 3 represents the delivery of air at constant pressure P2. The delivery of compressed air stops before it reaches point 4. Drag the crank to see the pressure volume variations. This is a theoretical cycle and it is assumed that the piston will expel all air. Hence, the volume of air induced in the cylinder is same as the volume of air swept by the piston. The relationship between the induced volume and the swept volume is the volumetric efficiency of the compressor. You will note that the volumetric efficiency is 100% because it is assumed that there is no restriction at the valves and the piston expels all air. In practice, the volumetric efficiency of a compressor is less than 100% because the induced volume is less than the swept volume. Can you guess why? The compressor has a clearance between the piston and cylinder head known as the bumping clearance. The clearance volume is filled with compressed air at this stage. As the piston moves down for induction, the pressurized air remaining in the clearance volume expands. Induction of air starts as soon as the pressure in the cylinder drops below the atmospheric pressure. Therefore, the actual induced volume of air will be lesser than the piston swept volume. Also, in the actual cycle, the valves restrict the flow of air. The delivery pressure increases initially above P2 and then returns to the delivery pressure P2. The inlet pressure decreases below P1 and later returns to the induction pressure P1. Hence, the actual compressor cycle appears as shown. When air has to be compressed to higher pressures, it has to be done in 2 or 3 stages. In multi-stage compression, cylinders are arranged in series in such a way that compressed air from the first stage becomes the intake air for the next stage. The intercoolers are provided at the delivery of each stage to reduce the temperature of compressed air. The oil-water separator separates and drains the oil-water mixture. An aftercooler is provided at the final stage delivery. In two-stage compression, the air is inducted at the first stage, compressed, cooled by intercoolers and delivered to the second stage. In the second stage, air is compressed further and delivered to the air receiver through an aftercooler. The work done in compressing the air by 2 stages is represented by the area 1, 2, 3, 4, 5, 6. When air is compressed to the same pressure by single-stage compression, the rise in pressure will be continuous. Therefore, the work done in compressing the air by single-stage compression is represented by the area 1, 2, 7, 6. You can see that the work done by single-stage compression is more than the two-stage compression. Drag the crank to see the pressure volume variations.